Okay, so now let's move on to discuss E1 reactions, which are intimately related. You should view them as being the closely related cousin of SN1. And E1 occurs when we have some sort of alkyl substrate, once again with a leaving group, where iodide would be faster than bromide, faster than chloride. Same trend there. But now we are going to denote the reactant, or sometimes the solvent, as being a base molecule instead of a nucleophile. And step one, similar to SN1, is ionization of the carbon leaving group bond to give a carbocation. And we know that endothermic process of cleaving a carbon leaving group bond is slow to yield a carbocation that has no octet. From here, the base now gets involved in the mechanism and deprotonates one of the protons on what's known as the beta carbon. The beta carbon is adjacent or one away from the alpha carbon. So all three of these methyl groups are identical beta carbons in a tert-butyl cation. And that eliminates to give an alkene. So elimination reactions, whether they're E1 or E2, always give an alkene product. This step is quite fast. We know that carbocations form slowly and react quickly because they are very electrophilic, and this proton here is quite acidic.